For today's video, we are going to talk about performing basic operations with vectors. The first operation that we're going to talk about is vector addition. To begin, we're just going to define what our vectors are. So we have vector v here, and we're going to say that its horizontal component is v sub 1, vertical component v sub 2, then also vector u with a horizontal component of u sub 1 and a vertical component of u sub 2. When we're talking about vector addition is just going to be the sum of the two vectors. And the way that you do that is you add the horizontal components and the vertical components together. So if we take a look up here, vector v has a horizontal component of v sub 1, vector u has a horizontal component of u sub 1. So the sum of those two vectors, you're going to add those two parts together. And then for the vertical part, you are going to add the vertical components, v sub 2 and u sub 2. You'll see those two added together here. So add vertical components with vertical components, horizontal components with horizontal components. So it's going to be really important that you have the vectors written in component form. If they're given to you as ordered pairs, make sure you first write them in component form, then you can figure out the sum. Now, addition and subtraction are essentially the same operation. So if this were a minus sign here, you would just subtract the components. So subtract horizontals and subtract verticals. This is also a visual representation of this. So if we were to plot vector u in the coordinate system, starting at the origin, did the horizontal vertical component, then from the tip of that vector, if we were to then plot v from that tip of u and do the horizontal vertical, the vector that connects the origin to that final resting point, that's going to be our resultant vector, or the sum of the two vectors. Second thing we're going to learn is scalar multiplication. So this is not multiplying two vectors together, it's multiplying one vector by any real number. So in this formula, k is representing our scalar. It could be any real number, a whole number, a fraction, a decimal, an irrational number, anything like that, but any number multiplied by a vector, u representing our vector. The way you're going to do this is basically distributing the scalar in. So you're going to distribute the scalar into the horizontal component and to the vertical component, just multiply it in there. One thing, so if you notice on this visual representation of multiplying is when you multiply by the scalar, it changes the length, or what's called the magnitude of the vector, being how long the vector is. So if you're going to take vector u here, this blue one being our original, and you're going to multiply it by 2, the resultant is just going to end up being 2 times bigger than the original vector, and it's going to go in the same direction. The arrow is going to be pointing in the same direction. Or if you multiplied by half, the magnitude is going to be half the size of the original. And then what happens when you multiply by a negative? When you multiply by a negative, it flips the direction of the vector. So the arrow is then going to be on the opposite end. So with this final one here, we flipped the direction with the negative, and we also doubled the length, or doubled the magnitude. So it's twice as long as this original one and flipped around. Let's go ahead and practice doing these a couple times here. We're going to first do scalar addition so we've got vector u here that's got components of -1, 3, and then vector v that has components of 4 and 7. So we're just going to go ahead here and add those together. I'm just going to write them both down. So u was -1, 3, and then we're going to add v to that, v being 4, 7. And what you're going to do here is you're going to take and you're going to add the -1, and I'll write it down so you can see it, -1 plus 4, because you're going to take the two horizontal components and add them together. Then you're going to take the two vertical components, 3 and 7, and add those together to get your resultant vector of 3, 10 when you simplify. So remember, add horizontal to horizontal, vertical to vertical to get that resultant vector. Part B, we're going to take and do a scalar. So 3 is the scalar. We're going to multiply that times vector u, which is -1, 3. Remember, when you're doing a scalar, you just multiply the scalar into both components to get your final answer. So 3 times -1 is -3, and then 3 times 3 is 9 for our resultant vector of -3, 9. Part C, we're going to do 2 things. Okay, a couple of things here. So you're first going to multiply the scalars in. So we're going to multiply 2 times the u vector, which is -1, 3. And then we're going to add on multiplying -1 times the v vector, which is 4, 7. So when you get multiple operations together, remember to just follow order of operations. So order of operations says to multiply first. So we will do the scalar multiplication first, and then we'll actually add those 2 vectors. So let's go ahead and multiply the 2 in. So we're going to get -2, 6. And then we'll multiply the -1 in. So we get -4, 7. -4, -7, sorry. Then go ahead and add those. So -2, so we'll end up doing the -2 plus the -4, adding those horizontal components. And then we'll add the vertical components together as well of 6 and -7. Then once you simplify, you get -6 and -1 for your final resultant vector of that. So just remember as you're going here, so we've got vector addition, which is just adding together your horizontal component to your horizontal component, vertical to vertical. Remember, if it's subtraction, you just subtract them, so just be careful on that subtraction operation. And then for scalar multiplication, you simply just distribute the scalar into the vector. And that's it.